All right, so today we're going to continue with area of regular polygons. You need to stop and listen. So this is the same exact thing you've had before, except instead of using 30, 60, 90, and 45, 45, 90 triangles, we're now going to use sine, cosine, and tangent. So what if, when we find the central angle, we don't get an angle that's 30, 60, or 45? What do? We can use sine, cosine, or tangent. And so let's do a little review. Question 1, area is the number of cubic or square units needed? Square units. Then circle the formula for the area of a triangle. Which one's the area of a triangle? First, second, third, or fourth? The second one. And then your vocabulary is just essentially trigonometry, which we're going to use. So then look at number 3. The sine, cosine, and tangent are ratios are trigonometry or trigonometric ratios. Trigonometric. Say that 10 times fast. This year I am studying what? Trigonometry. Actually, you're studying trigonometry in this class, dear.
Yeah.
All right. Then I want you to listen. You need to listen today. I don't have time for all your side conversations. So for 5, 6, and 7, I want you to draw a line that goes to the appropriate trig function. Sokotoa, some old hippie caught another hippie tripping on acid, right? So number 5, opposite over hypotenuse is what?
Sine.
Number 6, adjacent over hypotenuse is, and so by process of elimination, tangent must be opposite over adjacent. So then we come to problem 1. Problem 1 essentially takes up the entire first page, doesn't it? So I'm going to do, I guess I'll follow along with what they've got. So let's go through this. So we have a regular pentagon with 4-inch sides, so that's all that they gave us. And we're going to round our answer to the nearest square inch. So underline the correct word to complete the sentence. To find the area using the formula 1/2 AP, or I like to use PA, doesn't matter. You need to know the length of the what? Apothem. And the perimeter. So those are the things that we're looking for. The 4 inches allows us to find what? The perimeter. We can also use it to find the apothem, can't we? Right? Because if you recall, isn't this 4 inches here as well from here to here? So that means that this side right here is cut into 2 equal pieces by that apothem. And so each of those pieces is going to be what? 2 inches. And so we end up with this being 2 inches and this being 2 inches. And then this is going to be our apothem. And then and then we've got our radius, which we won't need for this problem. And so number 9 says in the regular pentagon at the right, label center okay, we're not going to label those. We're just not. It's too much in the picture. So number 10, the perimeter of the pentagon is 5. How do we know that? Okay, so that 5 is your 5 sides, right? So this is 5 sides. So we want it to be 5 times 4 inches, which is 20 inches. So that's one of the pieces of our puzzle, isn't it? So we've got perimeter. So this equals P. So check. We're done with that part. So what's left to find? Well, the apothem, right? And we're going to use the central angle to find that apothem. So here we go. We're going to find that central angle. So what do we divide 360 by? 5 sides. So what happens when we divide 360 by 5? What do we get? we get 72 degrees. So from here to here is 72 degrees. From here to here, the whole central angle, so that's both of these two angles together, is 72 degrees. And so what that means is we're going to take that 72 and cut it in half, won't we? And so that's what they're doing here. They're cutting the angles in half. And so we're going to take half of the 72 and half of the 72. And don't we get 36 degrees? So that is not a special angle, 36 degrees. So at this point, this triangle is really too small to try to put that in there, so we've enlarged it, if you want to consider that enlarged. So the 36 degrees is right here, because this is half of that central angle. So our 36 degrees goes here. What's left for, and then we already know what this side length is here, right? What's that side length? 2. So we've got 2 inches. And so we need to find, well, we don't actually have to find, we don't have to find this angle. You could if you want to, but remember with trig, all I need is one angle and a side. Or really just one angle and a side is going to get me to find all the rest of the sides. And since I'm interested in this side right here, and I have this side right here, are these two sides both legs? Is one a hypotenuse and the other one a leg? What do I have? I have 2 legs, right? And so this is my angle of reference right there. Thank you. If that's my angle of reference, is this side right across from the angle the side opposite, the side adjacent, or the hypotenuse? This side right here is adjacent? It's touching it? So that's the opposite. So this is going to be opposite. And then what is this side right here? That's adjacent, so it's leg adjacent. So what trig function, sine, cosine, or tangent, has opposite and adjacent in it? Tangent, right? Tripping on acid, tangent. And so they want you to circle the correct equation. So typically, we're going to choose sine, cosine, or tangent, so we just chose tangent. Do we know the degree? 36. So tangent of 36 degrees is equal to our opposite over the adjacent. So remember, because that's tripping on acid. And so what is our opposite? 2. And our adjacent, we're going to call what? A. I'm going to put that in red. So A is for your apothegm, not the adjacent, but they just happen to be one and the same. So then you're going to put that over 1, and we've got a proportion. So which one are we circling here? The very last one. Yes?
How do you know C is your equal? Because it's the angle measurement?
Because that's half of our central angle, and that's the angle that we just found. It's the only angle that we know. Now, could you have found this angle here at D? Yes. Bless you. You would have subtracted 36 from 90, and you could use that angle, but then these sides change. This would now be the side opposite, and that would be the side adjacent. You could do that. We typically don't. It's just one more step that we don't need to do. Okay? All right, so we're going to solve this equation right here by cross multiplying. And so that's what... Why did they use 72? I have no idea. I know, but I would never... Why would they have done that? Weird.
They're crazy.
We're not doing that. Okay, so then, as we cross multiply, do you see how they got A times the tangent of 36 degrees here? And then, what is this going to give us? 2. So we get 2 here. And then how do we solve for A? Divide by tan of 36. And so this part is missing here. So it's 2 over the tangent of 36 degrees. So when you use your calculator, what do you have to remember, especially if you're using a graphing calculator, what do you have to remember to make sure that that calculator is in? Do you remember? Yeah, so make sure that your mode is in degrees. If you have a scientific calculator that has a large display, make sure that on that display it says DEG. Does anybody not have that? Not able to find that on your calculator? Because this is what we're putting into our calculator, exactly as you see here. But if your calculator is not in degrees, when you plug in the tan of 36, it's not going to work out. All right, so we're going to do 2 divided by the tangent of 36. And make sure you complete your parentheses around 36. And then we get we get 2.7527 ... So it keeps going. I like to keep, they're probably going to put this entire thing into here, which is fine. That gives you your exact answer. You could probably use this decimal out to, I typically would go out to 6 decimal places if you don't want any rounding errors. But if you want the most exact answer, we're going to put this entire fraction into here. So we've got that 1/2, the apothem is 2 over the tangent of 36, and then what goes here? Do you remember? P, perimeter, right? 20. So we've got 20 inches that goes here. And technically this is 2 inches here. So that's how we get our area of inches squared. And so if you take your, I personally would take the 2 divided by the tangent of 36 degrees and hit enter. Then multiply by 20. Hit enter. And then what do you do for this? You can divide by 2 or multiply by 0.5. Either way works. And then hit enter. And then we get 27.5276, and it keeps going. So if we want to go to the nearest, what'd they say? The nearest square inch. So we want to round here. Look what's next door. What's the nearest square inch? So it's 28, right? Because 5 bumps up the 7. So we get 28 square inches. Any questions on that? The only difference is we're using sine, cosine, tangent. Everything else is the same. The entire process is identical. All right, so let's look at the next page. So again, same thing. I'm not necessarily going to write down everything that they have here, but let's look at the problem. A tabletop has the shape of a regular decagon. How many sides does a decagon have? 10. So this is 10 sides. With a radius of 9.5 inches. So if they had not given you a picture, remember that radius always goes from the center to a vertex. And so this is going to make a really skinny triangle. Now is this the central angle right here? It's only half of it. So technically, when we find that central angle, it goes from here to here. And we are going to find that. So let's go ahead and find our central angle. What do we do? Facts. You're totally skipping that. All right, so let's go ahead and do that off to the side. So we're going to take 360. So this is step 1. 360 divided by how many sides? 10 sides, which equals what? 36 degrees. So this whole angle from here to here is 36 degrees. So I'm going to put over here, well, let's go ahead and put it down here. So down here, I'm going to split. I'm going to make this little triangle right here a whole lot bigger. So we know this side is 9.5. This is our apothem. And we now know, so if the whole central angle is 36 degrees from here to here, when I divide that by 2, what do I get? 18 degrees. So I know that this is 18 degrees right there. I do need to find this side here. Remember, if that's x, isn't this also x? What's the length of the entire side? Because I'm going to need that whole side to find the perimeter. That whole side is 2x. So I don't want to just solve for x, I do want to find 2x, but we're going to find x first. So here we go. This is our angle of reference right here. So according to the angle of reference, the x is side opposite, adjacent, or hypotenuse. Opposite. So this one's opposite. And then I don't want to use the a right now, right? Because that would be 2 unknowns. I need to use the 9.5. So the 9.5 is what in comparison to the 18? It's the hypotenuse. So what ratio uses opposite and hypotenuse? Old hippie. Some old hippie, right? So sine. So this right here is going to be used to find x. So we're going to do the sine of 18, right, is equal to opposite over hypotenuse. Well, our hypotenuse is what? 9.5. So we have to do, bless you, we have to do 2 different ratios. One to find x and one to find a, the apothem. And so we're going to put this over 1, cross multiply. X times 1 is where the x here comes from. And then we've got sine of 18 degrees times the 9.5. And that's actually our exact answer, because they want us to do what? Nearest square inch. So that's our exact answer for x, but we really want to find 2x, right? So they've taken here, and you can choose to do this if you want to, they've taken here, p is equal to what times the length of one side? The perimeter is equal to what times the length of a side? What goes here? How do we find perimeter? Take each side, the length of that side, and multiply it by the number of sides. So in this case, we have 10 sides, right? So 10 times the length of one side. So here's our 10. But x is not the length of a side. What is? 2x. So we need to put a 2x in here because that's the length right here of one side. And so 10 is still, move this up, 10 is still the number of sides that we have. And then we have the 2. So that's the 2, doubling our answer. And then our answer from over here is 9.5 times the sine of 18. So we have 9.5 times the sine of 18 degrees. And so 10 times 2 is 20. And so our exact answer for perimeter would be that. And so you're going to see that that's what they're going to put in to the general formula, 1/2 PA. Why are we not putting in the calculator yet? If I put in the calculator and I get a decimal, I'm going to end up rounding in the middle of my problem. If I round in the middle of my problem, I end up having rounding errors. And then you're going to find that your answer might be a tenth or a couple of tenths or a couple of hundredths off of what the answer is in the book. And that's why. So don't round in the middle of your problem. Keep it exact until the very end. So then let's go ahead and find the apothem ratio. So let's look at our values for the apothem. And then if this is my angle of reference, what is the apothem to that angle of reference? Opposite, adjacent, or hypotenuse. So this is the adjacent. And I have the hypotenuse, right? So adjacent and the hypotenuse is what? Another hippie? Another hippie would be what? Sum another hippie, cot another hippie, what? Cot another hippie, so it's cosine. So that's why we're using this one here. And so this is adjacent over hypotenuse. Our hypotenuse is 9.5. And again, we turn this into a proportion. And then we're going to cross multiply. So 1 times A is where they're getting the A. And then cosine of 18 degrees times 9.5. So the 9.5 goes here. And so this is what we're going to put in for our apothem. So now, don't we have our apothem and our perimeter? Yes.
How did you know to use the 9.5?
Because, okay, so I could have used x, right? But look at how complicated x is. Where'd it go? Look how complicated x is. I'd rather not use that. Plus, I'd rather not use a side that I calculated myself. I want to always use the side that they've given me.
Okay.
So typically, I will always use that. Now, if I made a mistake here, and I plug that in to my general formula, I'm still going to get the wrong answer, but I'm trying to not get as many wrong answers. So I will always go with the side that they've given me. Since that's still the side that they gave me, that's why I'm going with those two sides. But you could have used this one, and then what trig function would you have used? With adjacent and opposite. Tangent, right? So you could have. All right, so we're going to find area. So area is equal to 1/2 PA. So I have 1/2 times my perimeter is 20 times the sine of 18 degrees. And then my apothem from above is 9.5 times the cosine of 18 degrees. And you're going to put that into your calculator exactly as you see it. Again, making sure that your calculator is in degrees. I personally would do these first. So I would do 20 times the sine of 18. Make sure you end the parentheses on that sine of 18 because you're going to get parentheses on your calculator. If you have, if you're using a calculator that doesn't have a large display, I would find the sine of 18 degrees first and then multiply it by 20. And then times the cosine of 18 degrees, and I would hit enter. And then times 9.5, I'd hit enter. And then finally, I would deal with the 1/2 by either multiplying by 0.5 or dividing by 2. It's your choice. But I'm going to put this in the graphing calculator exactly as you see it. And you should get 27.919799 ... keeps going. Did we not get that? Anybody not get that? You got 27.6. Let me see. Oh, because you've got the... So try that again. What did you put in first?
I put the sine 9.5 sine of 18.
Oh, that's why. This is cosine. 9.5 cosine. Okay, you should keep on, right? Chris, you can always print this out too. Okay, anybody else not get that on their calculator? Are we good? Good. Okay. All right, so then to the nearest square inch, what would that be? Because we want to round to here, right, look at what's next door. There's a 9 next door, so it bumps that 7 up to 28 square inches. Then the last thing they're going to have to do is a new type of area formula. And they don't actually give you the area formula. You have to figure it out on your own. But they do say that the area of a triangle is half the product of the lengths of the two sides and the sine of the included angle. So half the products of the lengths of the two sides and the sine of the included angle. This is using SAS. So here, if they said 1/2 B times C, so here's B, side B, and here's side C, which is the included angle between side B and side C? A. And so they want you to find the sine of A. So what if instead, because there's 3 different formulas you could write for this. So instead, I could have written or 1/2. Instead of B and C, let's do A and B times the sine of, so if I've got A and B, what's the included angle in between A and B? C. So we would do the sine of C. Does that make sense?
Is that always sine?
It will always be sine. All right, so you write the third one. The third one is going to be, oh, look at that. Or 1/2, and I want you to do, we haven't done A and C, right? So do 1/2 A times C. What is the included angle between A and C? B. And so we would multiply this by the sine of B. All right, so then look at the last page. And then problem 3 is just that. What is the area of the triangle? Round your answer to the nearest square inch. So is this SAS? Yes. So all we're going to do is take area equals 1/2. Because I don't really have side lengths, I can't write my original formula, but I can do the 2 sides times, I'm running out of room, so I'm going to move it over a smidge, times the sine of something. So what are my 2 side lengths? So we've got 16 inches, I'm going to put inches below, and then 10 inches, right? Put inches below. And then I'm taking the sine of 34 degrees. So you can put this in your calculator exactly as you see it if you have a graphing calculator, or if you have just a kind of a rinky-dinky scientific calculator, I would find the sine of 34 degrees first, hit enter, and then multiply by 10 times 16, hit enter, and then divide by 2 or multiply by 0.5. And you should get so A is approximately equal to 44.7354. And it keeps going. And they want you to go to the nearest square inch, which is here. So with the 7 next door, do we keep it 44 or round it up? So we round up again. So it's 45 square inches. Okay? And it is now 8 o'clock, so we're going to finish up. We're just going to stop here.